Okay, so welcome to the fifth week of the course. After this week, we'll have 3 more weeks to go, and we'll pretty much be done. But before I actually get started for today, I just kind of want to bring everybody up to speed on what's going on in the class and how you're doing. So I did, for last week's recording, I did talk about I went over assignment 2 and what the requirements are and ways to try to improve on the assignment. So I've actually completed grading, but I'm looking through it one more time to provide additional feedback that's more tailored to your specific paper and topic and where some of you made a mistake. So again, if you guys had reviewed the last recording, I actually indicated that some of you are still not analyzing the correct data. If it's not the correct data set or it's not the correct variables. So I still saw a lot of that for this assignment. And unfortunately, that really impacts your overall performance because it's one thing to have a research question, a research hypothesis, and then not do the correct analysis, because then your interpretation, conclusion, and recommendations are null and void. So some of you still made that mistake. Of note are the people who looked at length of stay between acute and non-acute care hospitals. Someone had actually asked in the Ask Instructor portal on where to find this, and I did provide information there, but it looks like not all of you actually going to that portal to figure it out. So unfortunately, that kind of impacts your overall performance. The other thing I actually indicated in the beginning of the course is that when you're writing these reports, they're really supposed to be in past tense when you get into your methodology, because what you're doing with a report is you're telling us what you did and what you found and the recommendations you're making based on that. So while the introduction, could actually just pretty much introduce the topic, what previous research has shown, and why this comparison or this analysis is relevant, when you get into your methodology, you're supposed to say, this is what you did, not this is what you are going to do, because you cannot be going to do something and then have the results. No, so it should be in past tense. This data was analyzed. T-test was used to test the null hypothesis. The accepted level of statistical significance was P0 equals 0.05. And then when you get to the result, you're kind of doing the same thing because you've already done the analysis and this is what you're reporting. So you have one more assignment due for this course, which would be the one that uses a mixed methodology. Please, again, it's going to kind of be the same. This is what you did. These were your findings, and then your recommendations can actually be in the future tense because you're making the recommendations of what is to come based on your findings. In addition to doing that, you want to make sure that you're also citing all of the points you're making with credible references. So many of you in your papers actually had very, very good information, but you were not citing them with credible resources to support what it is. I knew they were credible because these are topics that we've researched and we know about, but you want to make sure you support your stance with the necessary literature. And the last thing I actually want to talk about also would be the referencing format. A lot of you still, you're almost graduating from the program. I would expect that you should be familiar with the required format for the program, which is the APA. Some of you are still not doing it correctly. You lose points for doing this. So please pay attention to this when you're doing your final project. Having said that, I'm going to go into the analysis. So this week, we're going to explore quantitative research methods in detail, which is really going to be the focus of the discussion question. So last week, there was no discussion, but this week you do have one. So you're going to notice that the focus is really going to be more on the quantitative aspect of research. And then we're going to, for the statistical analysis, we're going to be moving into something more advanced. So typically we've been doing the independent sample t-test, comparing 2 or 3 groups relative to one another. But what we're going to be doing this week and next week will be predictive analysis. And this really falls under regression analysis, where we're going to be able to make predictions about a particular outcome based on other variables. And I'll explain this in more detail. Okay. So when we talk about regression, there are 2 primary ones that we're all very familiar with. There are multiple kinds that are out there, but there are 2 primary ones, and all of the others kind of fall under, or they're a version of these 2 primary ones. So we have linear regression and we have logistic regression. For this week, exercise 4, we're going to be paying attention to linear regression. But before I do the demonstration, I want to kind of give you some background on the various assumptions behind linear regression. Like I stated earlier, it's actually used for, we're going to be doing predictive analysis. So regression in general is used to predict the value of a variable or outcome based on the value of other variables. When we're talking about linear regression based on the name, as you can see, it really shows, it's used for analyzing continuous variable. When something shows a linear relationship, meaning as one goes up, the other goes up. That when it's linear, that's kind of what it's talking about. When it goes down, the other is going down. And when there's no linear regression, then you just simply have a straight line that shows that the relationship is not linear. There might be a relationship, but it's not a linear relationship. But we typically use linear regression when the outcome that we're analyzing or we're trying to predict is a continuous outcome. So an example would be maybe hospital net benefits, right? Since this is what we're discussing in this course, how profitable a hospital or a facility will be based on certain factors, right? So hospital net benefits is a continuous variable. Another thing you can think of in general might be the income someone makes based on maybe their level of education, experience, and things like that. So income, we can analyze income as a continuous variable. And, the linear regression can be used when you put certain factors in. It will give you some kind of idea. Again, it's a probability. It's not always going to be the exact same thing, which is why you would notice that we always have what we call a 95% confidence interval. It just kind of puts it in a ballpark to give you an idea. Another characteristic for using a regression analysis, whether it's linear or logistic, is that you can use it to adjust for confounding. So going back to my original example of hospital net benefits, right? There are many factors that influence how profitable a hospital is. As you could see from all of the analysis you've been doing, there are many characteristics that we list, number of paid employees, number of interns, number of volunteers, number of beds, how many Medicare and Medicaid discharges the hospital has, whether or not it's in a high competitive, medium, or low competitive market. All of these factors play a role in how profitable a hospital is. And when you kind of look at these factors amongst themselves, some of them actually have influence on one another. So in order for you to kind of cancel out the influence of all of them, you would typically use a regression analysis to actually adjust for that. So that if there is actually a positive relationship, that relationship is as a result of, you would notice that the relationship is actually true and, not because of the other factors that have actually come into play. When you're looking at a regression analysis, there's always going to be a dependent variable and an independent variable. The dependent variable would always be the outcome variable. So it means that that particular factor is dependent on the other factors, which is why we always refer to the predictive factors as independent variable. So using the example I just gave with hospital net benefits, the independent variables would include hospital cost, hospital revenue, number of discharges, over a certain period of time, number of hospital beds. All of these factors help influence how profitable the hospital is. So those are certain criteria that you need to know about regression analysis. Just like with the t-test, the regression analysis has certain assumptions. It always assumes that the two variables are continuous, that there is a linear relationship between the variables, that there are no significant outliers. So this is why when you write your report, we always ask, did you see any outliers? And if there were, because there would always be a few here and there. If those outliers played any had any key influence on the final outcome. If it did not, then you may as well leave it in the data set. But if it skews the data significantly, then you want to take that out, which is why we always kind of ask you to generate plots to kind of have a visual representation of what you're analyzing. The data show equal variances along the line of best fit and certain other things. When we talk about regression, whether it be linear or logistic, and next week I'll explain what logistic regression is about. Linear regression can actually be in the form of a univariate analysis, which would give you this equation, or a multivariate analysis. A univariate analysis is when you're only predicting the outcome, which in this case is y, based on only one independent variable. So there's only one variable in the model. If you're doing multivariate, and this is where adjusting for confounding comes into play, you would have multiple independent variables in the analysis. And this is what the predictive equation would kind of look like. So what you will be doing this week will be starting with the univariate analysis, and then you would eventually end up with a multivariate analysis. Usually your final recommendations are based on the multivariate analysis, meaning that all of the relevant variables are included in the model, and whatever that the results of that analysis shows actually gives you a better picture or prediction of what is going to happen with your outcome variable. I hope this makes sense. If this doesn't make sense, please replay this again for this to make sense. So you would always start with a univariate analysis where you would insert one variable by itself into the model to predict the outcome. However, in instances where you all of those individual variables by themselves have a significant influence on the outcome, you would want to run a multivariate analysis with all of those significant variables in the model. And if they all keep showing significant relationship, then it means that those factors are critical. There are times that as an individual variable, they would show a significant association, meaning that the p-value will be less than 0.05. But when you put them in a multivariate model, those factors, some of those factors may no longer be statistically significant, which kind of tells you that, maybe 2 or 3 of those factors actually were influencing one another, and the system or the program or the model has actually adjusted for that. So that interaction has canceled out, and it no longer plays a significant role in predicting the outcome. For you to better understand this, I'm going to show a demonstration, and then we'll go from there. When you run a regression analysis, you're going to have an output. The output would include what you call the model summary table the ANOVA table, and the coefficients. For your exercise, what you will be reporting will be the values in this particular table of coefficients. That's what you will be reporting. However, this model here is actually very important because this is actually what tells you how well the model has run. You would always get an R, and you always get an R squared. An R can be positive and negative, but what really matters is the R squared, which is the coefficient of determination. And what this tells you, and this is always positive, is how well the model runs. So the greater this value is to 1, the better your model, which means that whatever that, so let's say you have an R squared of 0.7, it means that 70% of the variation that you see in the outcome is highly influenced by those other variables, which is the independent variables in the model. So the closer this value is to 1, the better. 1 almost means 100%. But if it's less than 1, the closer it is to 0 means that, yes, in as much as you see a significant association, only that percentage explains what you're saying. So there are probably other factors that you would need to take into consideration. So again, until I run this, some of this I've kind of explained might sound like gibberish, but let's get it done. So for the exercise, it says you should run a linear model predicting the impact of hospital beds, hospital ownership, being a member of a system, Medicare discharge ratio, Medicaid discharge ratio on the hospital net benefit. Again, some of these things, this might not be word for word as it is in your exercise, because I'm trying to combine the RStudio analysis with the Excel analysis. There's a slight difference. So my numbers and my values may not match yours. So please just make sure you're using the right data set and you're running the correct analysis. It may not be the same because I have made modifications to this particular instruction. So what you want to do, first of all, so it says once you do that, you should recommend 3 policies to improve hospital performance. So first of all, what you want to do is say, okay, remember I said earlier that when you have a model, you have the dependent variable, which is the outcome variable, and the independent variables, which would be the predictor variables. In this instruction here, you can see that multiple variables have been presented. You want to look and say, okay, then what exactly is the outcome variable that I'm interested in looking at? What is the factor that would determine whether I should be using a linear analysis or a logistic analysis? And when you kind of look at it, because it's saying you should predict the impact of all of these factors on hospital net benefit, which is the same thing as the hospital profit, right? So that's usually the most significant indication of performance over a certain period of time. So in this case, we know that the dependent and the outcome variable is the hospital net benefit. The independent variables, based on what's available here, are hospital beds, which is here, hospital ownership, system membership, Medicare discharge ratio, Medicaid discharge ratio. So I know that all of these should be the X variables, and this is definitely the Y variable. Because I know that hospital net benefit is measured as a continuous variable, then definitely running a regression analysis is most appropriate. So let me go through a demonstration exercise for you. Okay, so here we go. Again, I've modified my data set to look very different. So from the original data set that was made available to you at the beginning of the semester, you want to make sure that you take out all of those variables that do not matter to you, right? So again, what I really needed was my hospital net benefit, which for me is the outcome variable. I put that in column A here. Then I have the hospital beds, which was also one of the independent variables, Medicaid discharge ratio, Medicare discharge ratio, hospital ownership, and system membership. And of course, in this case, I put teaching hospital. Again, this is not what the instruction says. This is my demonstration. I have to repeat this so many times because people still send me emails saying that they're not getting the exact same numbers as I am. That's because I'm doing something slightly different. So when you do the regression analysis, what you want to do is, again, now I've only limited my data set to all that I need with my outcome variable, which is the Y, or the dependent variable, to the far left column. All right, so again, I'm going to do, let me do a univariate analysis first, then I will do a multivariate analysis. So you want to go to data analysis, and then you go to regression. Okay, click OK. By default, this data analysis option for Excel runs only a linear regression. For a logistic regression or other forms of regression, there's going to be an advanced tool that I will guide you through how to add that to your Excel file next week. But by default, what you have for this one is a linear regression. So obviously, as you can see, it's asking you for your input range. Remember, the Y range is always going to be the outcome, and the X would always be the independent or predictor variables. So my outcome in this case, I put it in column A. I'm going to select all of that. Again, this is what I had used previously, so I know this goes to 3031. And then I'm going to only do a univariate analysis, meaning I'm only going to focus on one outcome, one independent variable, one predictor variable. So I'm going to use hospital beds. And then I'm going to put this here. Again, I know this goes as far as 3031. I'm selecting labels here because I started from the very first row, and I want Excel to understand that that row is a descriptive role, and it has text there. So I'm going to click OK. And here is my output. Again, this is a univariate analysis because I only looked at one predictor variable, right? And you'll see that here. So let me take out what I don't need here. So if you look at this, this kind of looks like what the summary table in the instructions look like. This is what we expect you to report in the table, but of course, make sure you round up to the nearest, to the respective decimal places or whole numbers as instructed. So let me do this here. I'm converting everything to numbers. Again, some of you are still not doing this correctly. I have given you the option several times to come in and resubmit it, but some of you still refuse to learn about that. So I might not give you that option to do that again. I'll just grade whatever it is that you submit. So again, remember when I did the presentation, I told you you're going to have 3 summary tables. It's going to be the regression table, the ANOVA table, and then of course the coefficient table. These are the 3. So in terms of the regression statistics, remember I talked about the R squared, and then of course number of observations really tells you what the sample size is, which is 330 counties were included since this was a United States data set. The value that really matters to you here will be these values here, the R squared and the adjusted R squared. In this case, you can see that the R squared and the adjusted R squared are very close. So you could always pick the adjusted R squared. It just kind of is more sensitive to your analysis, but obviously the values are the same. So what this tells you is that, so your R squared in this case is 0.15. 0.15 is the same thing as 15% when you multiply it by 100. It's telling you that this just simply tells you how well this model predicts your outcome variable. It's telling you that 15% of the variation you see in hospital net benefits, right, benefits in this case is the outcome of the dependent variable, is only explained by hospital beds, which means the remainder 85% is explained by other factors. So again, it's an okay model, but it's not enough to actually really explain what's going on. So you want to be kind of conscientious of that when you're making your recommendations, and kind of advise that other variables be explored. You don't really need to pay attention to the ANOVA table this time, but when you come down here, this is what determines whether or not what you see is statistically significant. So again, remember, we only did a univariate analysis, only one predictor variable, which in this case was hospital beds. It tells you what the coefficient was. In this case, the value here is positive. If it's negative, there'll be a minus sign in front of it, but this is positive, which means that there is a positive linear relationship between the number of hospital beds and the hospital net benefits. Since it is positive, it means that as hospital bed number of beds go up, the higher the profit the hospital makes. Does that make sense? There is a positive relationship in front of the coefficient because there's no minus sign here, meaning as the number of hospital beds go up, the higher the hospital net benefits. All right, so that's that. Sorry, I want to. Then now you want to say, okay, I see that it's there, but is this relationship statistically significant? As you can see from this cell here that I've highlighted in yellow, the p-value is 0.0000, which means it's highly significant. So yes, in as much as the level of predictability of this model is not really high, the relationship between hospital beds and hospital net benefits is actually crucial. So it's something you kind of want to take into consideration, meaning that the hospitals, should try to have more beds, because if they have more beds, then it means they can have more admissions and things like that. So that's that for this. So now you're going to say, okay, can I run, let me do a multivariate regression analysis. In this case, what you want to do is you're going to add additional variables to see how all those variables impact hospital net benefits. So now you go back to data. I'm back to my original spreadsheet. I still have my outcome variable as, let me go back here. Sorry, go back to the original. I'm going to go to data, data analysis, regression. So now let me put all of these other factors in. The input range, input Y range still remains the same, but the X range is actually going to increase. So remember, I had it as only B, but now I'm going to extend it to include everything else I'm interested in looking at. So I'm going to go as far as F. And obviously this goes to 3031. Okay, and then click OK. And we're back to this. So as you can see, after I did that, the number of rows, right, for this actually increased, because now all of the independent variables have increased. So now I have hospital beds, Medicaid discharge ratio, hospital ownership, system membership, and all of that. So all of these have increased here. So it's now going to account for all of these variables in my analysis. Let me delete these. Okay, so it's here. Again, you want to make sure that all of these are numbers so that it makes sense to you. Okay. So obviously the first thing you want to do here is look at how well the model runs. Again, you're looking at the R squared. So again, only 15% is explained. So this model, only 15% of the variation you see in hospital net benefits is explained by all of the factors and all of the predictive factors in this model. So you also kind of want to take all the factors into consideration. So now let's come down here to determine what is significant. Again, remember, first of all, you want to look at the coefficients and see what is positive or negative. So total hospital beds, despite the adjustment, still remains positive. But if you look at the previous analysis, let me switch to that spreadsheet, you see that the value was actually higher there. It was 72867. But when you come here, it actually went down. It's 70490. So there's been some kind of adjustment, probably because hospital beds interacts with one of these other factors here, but it still remains a positive relationship. And when you look at the p-value, it still remains statistically significant. Now let's go to Medicaid discharge ratio. The relationship is negative based on the analysis I did, meaning the higher the number of Medicaid patients that are admitted into the hospital, the lower the hospital's profit. Again, that's what these data set says. You know, it may not always be the same for each hospital or the time frame. Same thing with Medicaid, Medicare and Medicaid, they're both negative, meaning as the number of patients or discharges or admissions for these kind of payers increase, the lower profit the hospital makes. System membership also kind of shows a negative relationship, and then hospital ownership kind of does the same thing. But when we come here, we want to look at the p-value. So the only things that are statistically significant here are the number of hospital beds and being a member of a system, because it's positive. So in as much as Medicare and Medicaid discharge ratios show a negative relationship, they're not statistically significant. So you don't really want to worry about them, right? You know, just kind of put that at the back of your mind as part of the recommendations, meaning they should, because you can't turn away Medicare and Medicaid patients, they have to see them, but maybe the hospital should actually also try to target their advertising also to commercial payers and things like that, just to kind of increase revenue. But obviously the key things they want to remember from this analysis is to increase the number of hospital beds and also consider being a member of a hospital system. Perhaps through being a member of a hospital system, they're going to be able to, you know, have access to more patients. Obviously, that would also increase the number of hospital beds that they have, because once, you know, they have more of a system, they're able to reach more patients across various geographical areas, if that's something that matters. So that's how you will kind of interpret this and understand that. So I hope this demonstration has been helpful. We don't have much time left for the session, but feel free to ask me any questions if this doesn't, when you're doing this and you run into any issues, but please do not do it on the day it's due, because I may not be able to help you on that day. So you need to kind of ask me in advance. All right. Having said that, that's all for this week. And if nobody has any questions, I will stop recording and you know, let you go back to your Saturday afternoon. Okay. All right, so I'm gonna stop now and take care, okay?